All right, so just a quick video to go over this particular worksheet because I um, didn't have a chance to go over it in class. So yeah, sorry, I've done this like 3 or 4 times now. The heat is, anyway. So I've started by drawing the special triangles with the ratios that we learned, so technically the ones that come from the unit circle, at the top. So our typical ratios for the special triangles are drawn right here. Because a lot of these questions you can actually just treat as similar triangles, and the math is actually super simple. Now, your 45-degree triangles are kind of the exception where it's not always easier to treat them as similar triangles, but I'll give you a different method for those. And basically, with each question, you could just kind of evaluate what method you find is the easiest. So for 45 degrees, first of all, if you are given one of the sides opposing that angle, then you automatically know the next side because we know that if this angle is 45 degrees, this one's also 45 degrees, which means that these two sides have to be the same. So immediately you can fill in your 2 root 2, which means you can then solve for the hypotenuse using Pythagorean theorem if you wish. You can also, for any of these questions, do SOHCAHTOA, right? This is our angle, this is my opposite, this is my adjacent. So if I wanted to start by solving for the opposite, then the opposite is what I'm looking for, the hypotenuse is what I have, so you'd solve using sine. And then your third side, you could, again, either solve with Pythagorean theorem or with SOHCAHTOA again. So SOHCAHTOA is almost always an option. And then once you have two sides, you can always use Pythagorean theorem as well. So the other method that I want to show, similar triangles, that one's actually easier with the 30 and 60 degrees. It sometimes works just as easily with the 45 degrees. I just find more often than not, it's a lot easier with the 30 and 60 degree triangles. But again, those are, you still have great options, whether it's 45 degrees or the 30 and 60. And I'll review all three at the end and kind of explain again how you can use any of those three options for any of these triangles. Okay, so let's just look at the 60-degree triangle here. So I knew I drew the specialty triangles at the top, but I'm just going to draw them again just so we have them closer. So my 60-degree triangle, I know that my opposite side from the 60-degree triangle is radical 3, my adjacent side is 1, and my hypotenuse is 2. So I'm just going to compare. So the only side I have in this triangle down here, the one I'm trying to solve for, is 16. Well, typically my hypotenuse is 2. So how much bigger is this triangle? Well, 2 must have been multiplied by 8 to get 16. So this triangle is 8 times bigger in every way. So I can take the other two sides and multiply them by 8 to find what they are. So if I start with, let's just label, so this would be opposite. This is adjacent, this is opposite, this is adjacent, just to make sure we do the right math in the right spots. So typically my opposite side is radical 3. If I times that by 8, it's just 8 radical 3. So x must be 8 radical 3. And my adjacent side is typically 1. If I times that by 8, that's 8. And that's it. Those are the sides of my new triangle. So like I said, similar triangles, that's one option for solving for these. As long as you have those triangles memorized, that's going to be an easy option for most of these. So you can treat it like a similar triangle. And then of course, there's SOHCAHTOA. It's always an option. And Pythagorean theorem. Okay, so you can use any of those for pretty much all of these. The only reason why I say kind of evaluate each time is that sometimes the similar triangles isn't the easier method. Like if I scroll back up, this second one here, similar triangles isn't necessarily going to be helpful because our hypotenuse is usually radical 2. So where you could figure out what radical 2 must have been multiplied by to get 4, it is definitely a little bit harder. So using SOHCAHTOA would probably be a better method there. But 9 times out of 10, similar triangles are going to be fairly easy for you to figure out. And again, with your 45 degrees, most of the time you're given one of those adjacent or opposing sides, which means you can automatically fill in the next one anyway. So that's it. Those are your options. It's pretty simple. I'll do one more similar triangle for anyone who maybe thinks they want to see a second one. If you feel like you're good, you can stop the video at this point. Okay, so again, I'm going to start by labeling. So this is opposite, this is adjacent, and this is hypotenuse. And then I'm going to draw my other triangle for 30 degrees. So the one that we're used to. Hypotenuse is 2, opposite is 1, and adjacent is radical 3. And then you just compare. So I was given the opposite side. So I'm going to look at what's the opposite side here. The opposite side is 1. In this triangle, the opposite side is 2. So obviously, this was multiplied by 2. Or you can think of it as this triangle is 2 times bigger. So you're going to take your other two sides and just times them by 2. So what's 2 times 2? That's 4. So my new hypotenuse is 4. What's radical 3 times 2? It's just 2 radical 3. And that's it. Okay, so that's another example for using similar triangles. Super simple. Again, SOHCAHTOA is always an option. I don't feel I need to go over that because it should be second nature by now. And then Pythagorean theorem, once you have two sides, is always an easy option as well. Just remember to keep things as radicals, not decimals. That's it.